Hi, I'm Chris, a member of the President's Cup team. Today we'll be going over Car-tastrophe. This challenge was part of President's Cup 6, Teams Round 2. The scenario involves a spy who is transporting an encryption key, which is of the utmost importance to national security. It's our job to exploit a vulnerable smart car API, which is based on a real vulnerability, and extract the encryption key being stored on the vehicle's CAN bus. The challenge has 5 parts, or tokens. First, we need to exploit the API to drain the battery by running the air conditioner. Next, we extract the encryption key being transmitted by a CAN device that our team has installed on the target vehicle. Third, we need to find the other half of the encryption key. Fourth, signal to our agent in the field to remove our installed remote CAN device. And token 5, the target has caught on to what is happening and is making a break for the border to escape. We need to prevent that by tricking the vehicle control module into believing there is something wrong with the brake pressure of the vehicle. Note that in our instructions, we are given a specific VIN, which is our target vehicle. Let's get started. Once we log into our machine, we can navigate to Firefox. And in the instructions, we were told that we have a pfSense instance. So let's go to that and begin a packet capture. The login here is admin, Tartans. And we'll go to diagnostics, packet capture. I'm going to change the packet count to infinity and start our packet capture. Now it's not going to take long to get packets, but we need to let this run for a few seconds so that we can ensure that we're getting all of the CAN or the API call possibilities. So we're going to let this go for a little bit longer. We can see that we're getting some traffic as we expect. All right, that's probably enough. Let's stop the PCAP capture, and then we'll download the resultant PCAP. Once completed downloading, we can open that in Wireshark and view our results. Okay, good. We can see some HTTP traffic in here, and that's exactly what we're looking for. So let's go ahead and filter by HTTP to narrow things down a little bit. As we go through this, we can see some different API calls: battery status records request, my car finder request, remote AC, and so on. So let's just try a couple of these and see what kind of information we can get. Let's try a remote AC records request, which I have highlighted now. I'm going to go ahead and copy that value and paste it into Firefox. And what we get is a JSON object with some information. The key things we're looking at least for this token, is the plug-in state. And this particular vehicle, will note the VIN is not our target vehicle. This is a separate vehicle. But we can glean some information from this. So this car is connected, so it is plugged in. And remember, for token 1, we're trying to drain the battery. Also, the AC operation is stopped, so the air conditioner is not running. Okay, so we do have a specific VIN that we need to target, and I'm going to copy that information into a document in our environment here so we can deal with that a little bit easier. I'll go ahead and just open up a text editor here. Oops. Okay, there we go. I'm going to copy that VIN. I'm going to replace this VIN here in our URL, in our request, with the VIN of our target vehicle. If I just do that, we see that the DCIM value is either expired or invalid. Now, the exploit for this particular vulnerability tells us that if we just remove a value altogether, there is no check. There is no validation. So here's our target vehicle information. The plug-in state is not connected, and our air conditioner is not running. It is stopped. That's great. So we have an opportunity to turn it on and drain the battery. So let's do just that. Again, back to our PCAP here, we can find an AC remote request is what we're looking for. AC remote request. Again, there's a DSIM and a VIN that is not associated with our target vehicle. So let's go ahead and copy that value. I'm going to open up a new tab here, paste that, remove the DSIM, and add our VIN in the appropriate value. And we hit enter, and we got a success. So we got a success message from our user ID of SuperSpy007, and we can go back to our records request here, our status record that we did, and just hit refresh on that. And remember, we have plug-in state not connected, remote AC is stopped. So let's hit refresh after we sent that last command, still not connected, and the remote AC is on or started. So that's fantastic. We have a not connected battery or a not connected car with the AC on in hopes of draining the battery, which was the instructions for this part of the challenge. Now, if we go back to our grading page, we can grade the challenge, hit refresh, and there's our first token. Congratulations. Let's copy that out of our environment. Go back to our game board and paste our token answer here. Go ahead and submit along the way. And there we go. We nailed it. Okay, on to token 2. Let's go review our instructions up top. Our agent has intercepted the requested mechanic and installed the CAN bus device to grant remote access at 123.4567.2. Extract the encryption key being transmitted by the device with this ID. Let's get back into our environment. We can do this a couple of different ways, and those are outlined in the solution guide. We're going to go ahead and write a script that makes this connection and extracts the encryption key. So I am going to open up a terminal. I'm going to create a new file for token 2. Adjust my formatting as I paste in my code. Save that file. And double check my work. Let's import instead of import. There we are. All right, we're going to run token 2. And what we're doing here is making a socket CAN-D connection on the appropriate host and port and filtering by the ID that we were given in our instructions. Now what we can see here is we're printing out the data within that packet. So let's go ahead and Control-C that to stop. This is in fact the encryption key, or half of it, as we'll find out, that we are looking for as token 2. Let's go ahead and paste this in here. I'm going to clean it up a little bit. Copy this out. Onto my clipboard. Go down for Q2 or token 2 and submit. right, got it again. So we're 2 tokens in, and that was token 2. And so now we have to find the value of the token being transmitted by the secret CAN device. So token 3, our encryption key is incomplete, we find. Compare the transmitting CAN devices with the documentation to find the other half of the key. So let's get back to our environment. Open up our challenge server, our grading server. If we get to that home page again, we can see that if a challenge has files to download, we can access them here. Let's get those downloaded. Download, download, and this one will open up for us. Okay, so now we have a spec sheet that we can review, and we have a README. It gives us some further instructions. This is actually more appropriate and pertinent to token 2, but we can review that. And finally, some CAN messages. Again, the spec in Excel rather than PDF. So some resources here we can inspect and figure out where the rest of our encryption key might be. Upon further inspection of this spec document or spec sheet, we're going to get some interesting message IDs. From this, we can make a list, or we can go through them all and inspect the results. Let's go ahead and skip to the answer here. 342 gives us some interesting notes and discussion, so that piques our interest enough to add it to the list. What we're going to do is we're going to use the PyCAN or the Python CAN library to effectively expand on what we did for token 2. Going through the documentation, we might find a couple other interesting message IDs, and one will be chosen at random when the CAN server is started. The ID transmits the message and then waits 30 seconds to broadcast again. The ID transmits 1 byte every second. The full time for a message to appear is then 38 seconds, given this spec. This can be extracted using PyCAN or Wireshark using the same code or technique as we did before. A team solving this in competition would most likely not make this exact list and would inspect each of them individually to get to the answer. Let's go ahead and copy over our script and get this running. So again, I'll open up the terminal, PI token 3, adjust my formatting, and I'm going to insert this time, paste my script, and again, 342 is what we're actually looking for, but we threw some other ones in the list here to provide some realism. All right, so let's save that. And kick it off. This is going to take a minute, so I'm going to fast forward or pause here, and we see packets coming in. We'll come back to this here in a second. Okay, I've went ahead and interrupted the script here and stopped it. We're very fortunate in this case that we happened to catch the first packet as the first packet. However, we wouldn't expect to be able to do this each time. So again, with the instructions and the spec, we're told that there's a 30-second gap. So looking at the timestamps from here to here is a 30-second gap. So that means this happens to be the first packet in the series. Again, we just happened to get lucky and got it as the first packet in our capture. So we have to take the packets that go down to the next 30-second gap there, again from 04 to 35. It's close, but certainly more than a 1 second gap, and string all these together as our third token. Let's go ahead and do that. Just type this out. That would have been easier to do otherwise. Let's do Back to our sheet here. Type it out, 9379 AABC47 80 D462. And there's our token. So let's copy this. Let's copy this out of our environment onto our local clipboard, back to game board, and submit token 3. Great, making good progress now. On to token 4. We have to signal the agent. Again, let's review our instructions. We have to signal our agent that the key has been extracted because we have just completed that. The agent expects to see the AV unit turn on the climate control display and show 255 as the user requested fan speed. So the AV unit climate control should show full blast fan speed. Let's get into it. Okay, going back to our environment, we can review the documentation. On page 8 of the PDF, we have some message IDs that relate to the climate control and displays. First, let's take a look at 54B. As this one mentions fan speed, the first byte is the display turn on alert and needs to be 01 to alert the AV system to display the climate control pane. That's exactly what we're looking for. But we also have 510, which is responsible for informing the AV that the climate control is on. Similar to the first ID we looked at, the byte needs to be 01 to signal that there's a change in the climate control power. The fourth byte contains 2 values. The most significant bit is a flag, where 1 means the climate control is on. Bits 1 through 6 represent the climate control power. According to the notes, the power must be non-zero for the message to be processed. The last byte is the ambient temperature. We can ignore that. So we need to send 2 messages constructed to the demands above based on this spec, and then we can accomplish this with Python can again. So let's go ahead and get a script going for token 4. Get that out of the way. Okay, so token 4. Adjust my formatting, insert, and paste my script in there. So based on the spec, behind this window, we can see that we're using message ID 510 and 54B like we just discussed. Let's go ahead and save that. Token 4, getting ahead of ourselves. We run that and pause for effect. Okay, after no troubleshooting at all, I just simply ran the script again and get no errors. Heading back to our challenge server, let's go back to the home page here and grade our challenge, and this is where we're going to see our results. That we signaled to the mechanic that we successfully extracted the key and he can remove the device. We got our token by sending those 2 messages defined in our token 4 script. Again, it's all in the spec, and we talked about these values and the message IDs. So let's copy that token out of our environment, paste into our game board, and submit. Solid progress. Okay, we're on to the last token. Here, we're going to enter the token awarded after we successfully stop the car. So let's review token 5 requirements. The target has caught on to us and escaped before our agent could extract the device. Stop the car using the CAN bus by tricking the VCM into believing something is wrong with the brake pressure. Let's take a look at that. Okay, back over into our environment. Again, referencing our documentation, we find a very clear message ID related to brake pressure. We could see that bytes 0, 1, 2, and 3 relate to brake pressure. Effectively, what we're going to try to do is overload this, similar to a denial of service attack. We can see this packet is transmitting values between 40 and C0 to mess with the brake pressure. We're going to spoof many fake messages with a pressure reading of 0. This, again, can be done with our Python can library, and the brake error will trigger after 100 bad readings in a short period of time. The reading is considered bad if any of the 4 brakes are not between the regular values. So let's go ahead and get our script copied over for this. VI token 5. Let's go ahead, set our formatting, insert, and paste our script in. Again, we're going to send at least 100. Let's go ahead and overdo it just to make sure. And then our message is 1CA, our message ID. We see that again here in the spec. And then we can just set all of our data bytes to 0. That's outside of the normal range for a brake, for all of the brakes. And we'll just continue to send that message until we've effectively disrupted the VCM and tricked it into thinking that there's a problem. So let's go ahead and save this file. Start that. And the messages are sending. And we can go ahead and let that just keep running until we see the token pop up. And there we go. It goes pretty quick. So no need to sit there for a long time. We went ahead and just overloaded it right away. And we can copy this final value into our clipboard, or out of our environment, I should say, onto my local clipboard, over to game board, token 5 paste, and submit our answers. There, we did it. Congratulations. That was Car-tastrophe, again from President's Cup 6, Teams Round 2.